In this video, we're going to learn how to apply E in some real-life situations. To begin with, we're going to use the natural base to help us do some more investment problems. In section 8.1, we use the investment formula A equals P times 1 plus R over N to the RT power, or excuse me, to the NT power, where we had A be our final amount. Oops. This is our final amount. R is our percent rate that we're given for our investment. N is the number of times we compound, so number of times we compound per year. Number of times we compound per year. P is our principal, our starting amount, right? And T is our time in years. Now, one thing that happens that's kind of interesting is you can compound more and more and more per year, and you can actually compound continuously or just infinitely many times. So if n goes to infinity, right, if we compound infinitely many times per year, this expression 1 plus 1 over n to the n power, which is essentially our base, right, of this exponent, this goes to e. So if we compound continuously, or we say continuously compound, we use a different formula altogether. We use A equals P times E to the RT. This is a lot easier to use. You can see you don't have to worry about N anymore, and that whole fraction as the base. It's a lot easier. Let me show you a couple of examples. In example 5, it says, let's deposit $1,500 in an account that pays an unbelievable interest rate, 7.5%, that's compounded continuously. Guys, as soon as you read compounded continuously, you should write PE to the RT. That's going to be your formula. Well, we know the P value for this is going to be 1,500. We know the interest rate as a decimal is 0.075, and we're doing this for, I think, 1 year for part A, so T equals 1. So our amount A is going to be just 1,500 for P times the natural base E raised to the 0.075 times 1. So in my calculator, I'm going to literally type in 1,500 E to the 0.075, since 0.075 times 1 is just 0.075. So if we bring up our calculator, oops, I'm going to type in 1,500, oops, let's try that again, 1,500, and then second ln to get e to the power, and I'm just going to do 0.075, and we'd have $1,616.83. So let's write that down. That would be our solution for this particular problem. We're going to have, after 1 year, an amount of $1,616.83 if we just round to the nearest penny. If we did this for 10 years, everything's going to stay exactly the same as far as our amount for P. Our principal is still 1,500, and our interest rate is still 0.075. Here, the time value, though, is changing to 10 years. So in the calculator, it's going to go 1,500 E to the 0.075 times 10. Now I know if I multiply 0.075 times 10, I'm just going to move the decimal place over once. So I'll save myself a little work and just put in 1,500 E to the 0.75 power. And let's see what happens. 1,500 e to the 0.75 power, and I get $3,175.50. So for this problem, our final answer would be an amount of $3,175.50. Let's do our last problem here that I'm going to show you in the video. What if we did this for 50 years? Well, actually, I think this would be a good one for you guys to try. I would like you to calculate how much you'd have after 50 years. Maybe this will be one of the ones we'll have to check in class. The last example I would like to do with you guys is not a money-making problem. It is rather it's a problem that has to do with atmospheric pressure of an object that's d miles above sea level, and it's modeled by this natural base function p equals 14.7 e to the negative 0.21 d power. Let's answer these questions based on that equation. It says, how much pressure per square inch would you experience at the summit of Mount Washington, which is 6,288 feet above sea level? Well, this is a tricky problem because that distance, d, is not measured in feet above sea level, it's measured in miles. So what we have to do is first convert what this is in miles. Now if you remember some of these conversions, 6,288 feet, if I want to convert that into miles, I'm going to divide that by 5,280 feet for every 1 mile. So in your calculator, if you actually divide 6,288 by 5,280, you're going to get 1.2 approximately. So this is about 1.2 miles. So this is like saying, okay, just tell me what P is when my D value is 1.2 miles above sea level. So I would use my calculator and do 14.7 e to the negative 0.21 times 1.2. Now I'm going to show you how to put this exactly into your calculator. So in your calculator, what we're going to put is exactly what we had. It was 14.7. I'm going to hit second ln to bring up e to the power of negative 0.21, and then remember we're multiplying that to our distance of 1.2 miles. And I'm going to close parentheses, so I raise e to that entire product. If you'd enter, we're going to get a pressure P of 11.43 pounds per square inch. So the way I would answer this question, based on that value we just got, is the pressure is 11.43 pounds per square inch. For part B, it's asking, what if you were at the top of Mount Everest, which is the highest elevation on Earth, that is 29,028 feet above sea level? Well, here, once again, if we have that distance in feet, which is 29,028 feet above sea level, we have to convert that into miles, and we know there's 5,280 feet for every 1 mile. So essentially, in your calculator, we're going to have to divide the 29,028 feet by 5,280. And if you do, we're going to get approximately, let's see, 29,028 feet divided by 5,280. It's going to be about 5.5 miles above sea level. So that's quite high, right? 5.5 miles. This is our D value for this problem. So using that formula from above, our pressure is going to be 14.7 e to the negative 0.21 times 5.5. Well, in this problem, let's use our calculator again, and I'm going to see if I can bring it up. And here we go. So I'm going to do 14.7, then second ln raise it to the power of negative 0.21 times 5.5, and if I close the parentheses and hit enter, we get a pressure of 4.63 pounds per square inch. So our pressure here is about I should put about with the approximate signs, 4.6 pounds per, I'm going to write square inches like that, per inches squared. Notice as we got higher up, the atmospheric pressure drops, and that does make sense. There's less air up there, so the pressure is less. For part C, it says graph the model using your graphing calculator, and let's see if we can estimate our height if we were to experience 13.23 pounds per square inch of pressure. So here what they're doing, guys, is something a little different. They're telling us what the pressure is. They want a pressure to be 13.23, and we have to figure out what is that distance in miles above sea level. Now, this is kind of a cool problem because it will lead into the next section. Let me just write the equation if we substitute this in. We'll have 13.23 equal to 14.7 e to the negative 0.21 d. Now, we need to solve for d essentially. We don't know how to do that right now unless we use something called logarithms. If you ever need to find an exponent, logarithms are the way to go, and that's why we're going to learn that in the next lesson. But for right now, we have no idea how to solve this, other than using a trick we used last chapter, which was, if we want to solve an equation using our calculator, let's let one side be y1, let's let this side be y2, and see where they intersect. So you're going to watch me plug in 13.23 into my calculator for y1, and then this guy, and for y2, set up a window and solve, and then we'll write down the solution. So if you have your graphing calculator, or if you don't, you should get it, and try to follow these steps with me so you know how to do it in class when you practice it. So here we go. Let's bring up our graphing calculator. In for y1, we're going to type in that pressure we want, 13.23, and in y2, we want to type in the formula, 14.7, and then second ln to bring up e to the power of negative 0.21 d, which we're going to have to use x, and make sure you close the parentheses. Now remember, the whole idea is to try to graph this in a window where we can see what's going on, and I think if you just go to zoom 6, the standard window, you're only going to catch a little bit of your graph. Remember, y1 was 13.23, which is a horizontal line, right? Y equals a number, it's just a horizontal line. And the top of our screen only goes up to 10. So let's change our window so that, first of all, we go up to a y max of, let's say, 15, and then graph it. And right there you can see there's the horizontal line at the very top of the screen, and they do cross there. I'm going to show you a trick that I think I've shown you before. If you zoom box using number 1, you can use your arrow keys to bring your cursor around the area you want to highlight or box. So I'm going to put my cursor right there, hit enter, and just kind of drag a box around that intersection so I can see really nicely where those cross. Now if you recall from the last time we did this, in the last chapter, we hit second trace to bring up the calculate menu, and we want to find the intersection, 5. If I do that, I'm going to hit enter 3 times, one for the first curve, then it'll ask you for the second curve, hit enter, and then your guess, just hit enter again, and there you have the x coordinate, 0.5, that gives you the y value, 13.23. So to answer the question, we just figured out the x coordinate, or the x value, which is the same as our distance, right, for this problem. To answer the question is about 0.5. Now remember, the units for this were in miles. So that means we'd have to be about a half mile up in order to get that type of pressure. And actually, in the next section, we'll learn how to solve that same equation, but without having to use our graphing calculator. Thanks for watching.